Hey guys, welcome back to another interesting topic about digital electronics. Before going into the topic, I wanted to say one thing, that if you are a new comer for this channel, please do subscribe. That will help me a lot, and I will produce digital electronic videos every single week. And thanks for continuing till the end. So what's the signed binary number representation? So signed binary representation is used for us for representing a binary number in negative values. As we know, we have two things called positive numbers and negative numbers. So positive numbers are represented with plus sign and negative numbers are represented with negative sign. So but the problem over here is that we don't have plus or minus in binary form. All we have is ones and zeros. So with this ones and zeros, we need to represent a number which is positive or negative. So we have three methods for representing signed binary representation. So three methods are sign magnitude form and 1's complement and 2's complement. I will explain in detail with giving examples of sign magnitude. I'll compare all the three at the end. Please watch till end. So let's go into sign magnitude form. Sign magnitude, as you know, the name suggests we have sign bit and magnitude bit. Let us consider a binary of n bits. So we have n bits in the binary, and in that n bits we are going to take one bit for sign and other n minus 1 bits for magnitude. So one bit for sign and another n minus bit for magnitude. So how it works is that, what does that one bit represent? We have ones and zeros. All we have is ones and zeros. Understand this. We have ones and zeros. So here 0 represents positive number. So 0 represents positive number and 1 represents a negative number. So 0 represents positive, 1 represents negative. So how are we going to use it in the binary codes? So let us take an example. So let us consider an example of -7. So how do we represent -7 in sign magnitude form? So we have two things, sign bit and magnitude bits. So magnitude bit means representation of 7 in a binary form. How are we going to represent 7 in binary form? As 1, 1 and 1. So the sign is negative over here. As you know that 1 is for negative and 0 is for positive. Okay, so all we need to do is add an extra sign bit. This is a sign bit which we are going to add now, that is 1. So sign bit. So this becomes -7 in sign magnitude form. So we can do it for any number. For example, let's take -3. So how are we going to do this for -3? Similarly, add a sign bit which is negative over here and represent 3 in binary form. What's the 3 in binary? 0, 1 and 1. So this is a sign magnitude form. The problem with the sign magnitude form is that, you know, the problem arises when we have -0. Okay, so let us consider -0. So it can be represented in sign magnitude form. All it is that 1, and 1 is the negative number for -1. So it is minus, it's 1. So 0, it's 1, 2, 3 and 0. So there is -0 in sign magnitude form. So what? Is there -0 in our real numbers? No, it's not there. But we can represent, in sign magnitude form, we can represent -0. So that's a problem, and we are adding extra bit for it. So it is not so good approach for using sign magnitude form. So that's the reason we went for 2's complement form. So before going to 2's complement form, what's the range of a sign magnitude form? So the range of sign magnitude form is -2 power n minus 1 minus 1 to 2 power n minus 1 minus 1. So this is the range of a sign magnitude form. So let us consider of n is equals to 4. So 4 bit. As we have seen, -7 is represented in 4 bits. So we'll use 4. So 2 power 3 minus 1 and its whole minus to 2 power 3 minus 1. So it is representing from -7 to 7. So it requires 4 bits and it represents -7 to 7. Usually we used to represent 4 till hexadecimal values A, B, C, D and F, but it is restricted to -7 to 7 in sign magnitude form. So disadvantage of sign magnitude is that we have 2 zeros. It is 0 plus 0, and that is not good. It's valid point that we can get -0 and +0, but it is not the case we need. It is not correct at all. So that's the reason we moved to complement forms. So we have moved to complement form. We have 1's complement and 2's complement. So what's meant by 1's complement? 1's complement is nothing but by simply complementing the single bit. As you can see, I'll explain you with an example. Let us consider this example 1011. So this is a binary number. I don't know its value. You need to calculate. So all we need to do is to invert every single bit. And invert every single bit. So 1 inversion complement is 0, 1 complement is 0, 0 complement is 1, 1 complement is 0, and 0 complement is 1, 1 complement is 0. So this is 1's complement of the binary number. So how to get 2's complement? 2's complement is simple. 2's complement is nothing but 1's complement plus 1. So we need to add 1 bit, 1 to the 1's complement. So this is 1's complement. We need to add 1 for the 2's complement. So all the value we get is, I'm writing over here, okay, it's 1 0 0 0 plus 1 is 1 and nothing is there, all are zeros. So added 0 1 0 1 and 0. So this is a 2's complement value. This is a 2's complement value. I hope you are getting 1's complement and 2's complement, which are crucial for representing in sign binary representation. So this is 1's complement and this is 2's complement. So now let us look how this 1's complement are used in representing a binary in sign form. So I'm going to explain 1's complement. So as you know, in sign magnitude form we have 1 bit for sign and another bit for magnitude, another rest bits for magnitude. Here the case is similar, but the magnitude is 1's complemented. So magnitude is 1's complemented. That's it. The case is simple. Your sign magnitude, sign bit is same, magnitude bit is complemented. So let us consider the same example so that we will have some relation. So -7 in sign magnitude representation, it is represented as 1 bit for sign and 3 bits for magnitude. And in 1's complement, it is represented similarly. So all we need to do is sign bit will be similar and we need to complement this. We need to complement the magnitude 1. So 1's complement of 111 is 0 0 0. So this is represented in 1's complement form. So this is -7 in 1's complement form. So now we'll take one more example for your clear understanding. So -3. So -3 in sign magnitude form is represented as 1 0 and 1 1. So sign bit it will be same, and in 1's complement we need to complement it. So it is 0 0 and 1. So it is -3 in 1's complement form. So okay. Now let us look at the range and how can be a 0 represented. So we know that 0, we have 2 zeros over here, don't forget zeros and -0. So 0 means sign bit means it's positive, it's 0, and this is our magnitude. I'm just writing this indicate that this is a sign bit and this is a magnitude. There's no line in between, you can write it 0 0 0. So now minus 0 is represented by 1 and 000, and here also -0 is there. So what's the point over here? Okay, -0 is there. So this also fails. Just we don't need this also because -0 is not required at all. You know, -0 is valid. You can get through this complement form, but it is not required. And by the way, I have written wrong over here. It's a complement. Okay, it's a complement. Sorry for this one. It's a complement over here. I forgot to take the complements. All ones. -0 in 1's complement is all ones. Okay. Sorry for this mistake. But this mistake hasn't been solved. So we cannot use 1's complement comparatively. So we need to know the range of 1's complement. As you can see, the range will be similar to sign magnitude form. So this is the range of 1's complement representations in sign. So let n is equals to 4. So what will we get? The values are minus 7 to 7. So we cannot represent minus 7 to 7, but the problem is that we are having a negative 0. So to solve this negative 0 problem, we have come up with the 2's complement. So now let's go for 2's complement representation in how it's going to be used in sign binary representation. So now let's go for 2's complement. So 2's complement is nothing but 1's complement plus 1. That's it. That's so simple. 2's complement is 1's complement plus 1. So again we have sign bit, only one bit. Sign bit is only one bit. Magnitude, we have another bits. So this magnitude is represented in 2's complement form. As you know, 2's complement is nothing but 1's complement plus 1. Don't forget this. This is important point. Okay. So to get better understanding, let's go with an example, minus 7, how a minus 7 is represented. Okay. And one more important thing before going to minus 7, you know, this sign bit is also a magnitude bit in MSB bit. MSB bit is not only sign bit. In case of a 2's complement, it has a sign and magnitude. Don't forget it. It's MSB bit of a 2's complement has sign as well as magnitude. It has a power. It has a power of sign to indicate as a sign as well as magnitude, where in 1's complement and sign magnitude form, it was only MSB bit was only having the power of sign. It was not representing for magnitude. Okay, MSB bit is having sign and magnitude, whereas in 1's and sign magnitude form it will have having only sign. Okay, understand this. Don't forget this one. Okay, this has magnitude and sign. Okay, but I'm going to explain it clearly. Let's go with the example minus 7. So minus 7 can be represented like this in 2's complement form. First we need to find the 1's complement. So in 1's complement it is somewhat like this. Okay, it's like this. It's sign magnitude form. In 1's complement it is 1 0 0 0. It is 1's complement. Now we need to add 1 for this one. We need to add 1 over here, and what we get, the value is 1 0 0 0 and 1. So this is a 2's complement form. So this is a 2's complement form of minus 7. So minus 7 is represented as 1 0 0 1 in 2's complement. So if you want to convert it back, you know, if you want to convert it back from 1 0 0 0 to minus 7, how are we going to convert? So as you know, in the binary representation, binary to decimal, you are going to use 2 power 0, 2 power 1, 2 power 2 and 2 power 3. But this is a sign representation, so we have a one change. All we need to do is to add a sign to the last bit, to last MSB bit. So minus 2 power 3 is minus 8 plus 1, where 2 power 0 is there. So plus 1, minus 8 plus 1 is minus 7. So this is how you are going to calculate. Now let us look for one more example so that you will have a clear understanding what a 2's complement representation is. Don't forget, sign MSB bit in 2's complement is having sign and magnitude, whereas MSB bit in 1's complement is having only sign, and in sign magnitude form MSB bit is having only sign. Don't forget this point. This point is super crucial. So now let us look at another example, minus 3. So I want you to say the answer. So first we'll go with 1's complement method. So 1's complement, it is minus 1. 1 is for sign, and next 3 bits are for magnitude. So it is 0, 1 and 1. Okay, 0, 1 and 1. So minus 1. Now this is in sign magnitude form. Now we need to convert into the 1's complement. So what's the 1's complement? Its 1 complement is 1. Only magnitude we need to be converted. Okay, don't forget that. Don't convert the sign bit. So this is in 1's complement form. Now from 1's complement we need to get 2's complement. That is, add one more 1 for this. Add 1 for this. So what's the 1? 0 plus 1 is 1. 0 plus 0 is 0. 1 plus 0 is 1. 1 plus 1 0 is 1. So this is 2's complement of minus 3. So to get calculated value, again, to check this value, how are we going to check? So this checking is so important. Just have a look. Okay, so 1 1 0 1. So as you can see, while representing it is 2 power 0, it's 2 power 1, 2 power 2, and it is 2 power 3. And don't forget, this MSB bit is having sign plus magnitude. I'm shouting whole video that MSB bit of a 2's complement is having sign and magnitude. So add the sign 2 for it. So minus 2 power 3 means it's 8 minus 8. Minus 8 plus 4 plus 1. So what's the value? Minus 8 plus 5. It is minus 3. So this is how you calculate a negative value and represent it in 2's complement form. So now I have a small thing, comparison between all three sign binary representation. So this is how we compare. So as you can see, in sign magnitude form and in 1's complement and 2's complement form, the positive numbers have no change. In negative numbers, we have a change. See the negative numbers, all the MSB bit is 1 over here, MSB bit is 1 over here, MSB bit is 1 over here. And we have a certain change that is represented in normal form, and we have represented in complement form, 1's complement form. It's 1 0 0 0 is represented 1 1 1. In these two cases, we have minus 0, which is not correct, but in 2's complement, we don't have minus 0. So that's a small tricky question for you. In 2's complement, why we don't have a minus 0? So if you answer this comment in below, I will suggest you a method. Okay, answer this in comment. Why don't we have minus 0? Okay, this is a tricky part. And the range of minus 2's complement is, so range of 2's complement is minus 2 power n minus 1 to 2 power n minus 1. So if you take n equals to 4, it is minus 8 to minus 2 plus 7. So what's happening is that since we have no minus 0, we are getting an extra thing is called as minus 8. I hope you understood this one. We don't have minus 0. So I'm going to explain why we don't have minus 0. So we don't have minus 0. I'm explaining why we don't have minus 0. As you can see, minus 0 can be represented in sign magnitude form as 1 0 0 0. So how are we going to represent it in 1's complement form? In 1's complement is take the complement 1 1 1. This is in 1's complement form. So add 1 to it so that we get 2's complement form. So we are adding 1 to it. So now it's 0 0 0 0. So neglect the carry. Carry is being neglected, and this is in the 2's complement form. And we have that similar thing. Minus 0 is represented as 0 in here. Minus 0 and plus 0 are represented by zeros. So no problem, 2's complement rectifies that problem of having minus 0 over here. I hope you understood. Thanks for watching, and please do subscribe and turn on the notification bell. If you like this video, please do share. That will help me a lot to provide more good content for you. And thanks for watching. Please do subscribe. Don't forget to turn on notifications.